Okay, so we're just going to look a little bit more at circles and some important characteristics of circles. So what we want to do is we actually want to look at arc length. So an arc is this area around the circle. So here, if we're looking at this angle, the arc is this portion. It's the section of the circle that's intersected by the angle. We call that S. This is our central angle, and we call that theta, and this is the radius, r. The formula for the arc length is very simply S is equal to r times theta. And so from that, we can actually get other relationships. So r is equal to S over theta, which actually, if you look at it, S over theta, that's actually a radian, because if S was this whole distance around and theta is the central angle, this gives us the definition of a radian. We could also get the radius. Sorry, we just had the radius. We could also get that the central angle theta is equal to S over R. But for us, we just focus on this formula and we can manipulate it as need be. So one important thing here is that the arc length must be in radians for us to get through this. So if we look at the formula, S is equal to R times theta. Here, we want to find this highlighted arc length. So we have S is equal to R times theta. So the arc length there is equal to R, which is 12, times theta, which is 5 pi over 6. The 12 and the 6 actually reduce to 2 and 1. So we get that S is equal to 2 pi. Because the unit here is kilometers, that's what the length of the arc is as well. Over here for number 2, we again have S is equal to R times theta. So the arc length is equal to the radius, which is 9, times the central angle, which is 7 pi over 4. Now here the 9 and the 4 can't reduce, but that's okay. We leave this as 63 pi over 4 meters. Now that's actually pretty nice and pretty simple. But just be mindful, if they gave us a central angle as degrees, so say 300 degrees, we would need to first convert that to radian. So this must be in radians, and that is, of course, the angle theta. And that's how we find arc length, so pretty straightforward. We can also find the sector area. The sector is actually this portion here. So it's the slice of a pie, basically. That's what a sector is. A sector is a portion of the pie. So when we cut a pie, how big is the slice? What is the area of that slice? And that's what the sector is. Well, the area of a circle is pi r squared. And so what we're doing is we are dividing this by how many radians we have, or the total circumference for a unit circle, which is 2 pi. So this actually gives us, the pi's cancel out, and so we get r squared over 2. But we need to multiply this by that central angle theta again. So this is the formula for the sector area. So what you need to realize is that the formula is going to be r squared theta divided by 2. And that's it. So let's look at this again. So if we have that the area is equal to r squared theta over 2, the area is equal to r squared, so 7 squared, which is 49, times 3 pi over 2 divided by 2, or just times 1/2, is going to give us 3 pi over 4 times 49. So that's not going to reduce at all. So 49 times 3 is just 147. So we get 147 pi over 4. And of course, we're talking about area, so this is feet squared. For number 2, we use that same formula, r squared theta over 2. So the area is going to be 169, that's r squared, times theta, which is 5 pi over 12, divided by 2, or times 1/2. So 169 and 24, they don't have any common factors, so we just get 5 times 169, which is going to give us 845 pi over 24. The unit here is in inches, so yet again we have inches squared because we are talking about area. And so that's it. So real quick section about sector area and arc length. So 2 important formulas to know, 2 important relationships. So just play around with it and make sure that you can do these calculations.